Hey all, thanks for joining in. My name is Rishabh Mishra and I'm a machine learning engineer at Twitter, and I work on tweet reply ranking.
Um, Hey everyone, good afternoon. I'm Jigyasa Grover. I also work as a machine learning engineer at Twitter, particularly in the ads prediction domain. Based off our book titled Sculpting Data for ML, the first act of machine learning, this talk, we'd be talking about how to sculpt the right kind of data for our machine learning models. The last couple of years have seen an immense growth in machine learning in multiple domains, from influencing our shopping carts to cars self-driving themselves around the town. Unquestionably, machine learning is the most used and the most abused subdomain of artificial intelligence presently. It is being used in improving healthcare, advancing warfare, scrutinizing your resume, to determining your creditworthiness. So, regardless of our fascination or loath for it, it is influencing our decision making powers heavily, and dominating our lives as well. For this, there are dominant leaps that are leaving the scientists, investors, policymakers, business leaders, and the audience bedazzled that human like intelligence in machines might be just around the corner. Nonetheless, progress in machine learning has been impressive, but there's a lot of pending explanation and examination which keeps the research going on. Um, for the state of the art algorithms to work their magic, it's important to focus on three key dimensions: well calibrated data, sophisticated algorithms, and efficient computation. So these are the three main dimensions that we usually focus on. Since we've progressed so much from a rule based approach to a more data driven approach, it goes without saying that machine learning algorithms are trained to capture implicit information from the data we provide. Or to say that the approaches these days are very data hungry. Without going into like many technical details, we can, if you're familiar with deep learning algorithms, they have many parameters that need to be tuned, and therefore they need a lot of data to in order to come up with somewhat like a more generalizable model. So in that sense, having a lot of data is the key to come up with good training data sets, so that like we might think. So worthy data collection forms the foundation of the pyramid of AI hierarchy of needs. This is drawn parallel to the Maslow's hierarchy of human needs by Monica Rogati, who's like a renowned data scientist and AI advisor. She puts forward that data literacy, data collection, and data flow form the basic need which must be satisfied in order to achieve self actualization or nirvana, which in our case would be the attainment of AI. uh, Not to say that a lot of data is helpful, but the type of data that we feed into an algorithm has a profound effect on the success of an algorithm. Um, so basically, that's what the gist would be, that feeding the right format and the right type of data is what matters more than quantity of data. Or as Peter Norvig puts in very easy words, more data beats clever algorithms, but better data beats more data. Uh,
Yeah. Now let's talk about data curation. So I'll put forward like basically two aspects from academia and then from industry, and we'll see why data curation is kind of important in each of these uh, basically categories. So first thing is in academia, like the core machine learning and data science research groups are more oriented towards novelty and advancing the fields. And these are kind of weighted higher than like the money making logic that we usually see in the industry. So but in attempts to like solve new problems, apart from like finding relevant collaborators and finding fundings for the research projects, one big blocker they usually see is like access to relevant data sources, because they don't have any in-house mechanism that generates the data, which is usually the case for industry. So that's the thing that kind of motivates us to kind of learn about data curation, when, let's say, we are working in academia. Now, for the other aspect of when we are in industry, basically we see that in industry, like there is lot of in-house data, but the problem comes in identifying the key aspects that we can use and work basically on top of unstructured data. Um and usually there's another concern around kind of scaling the solutions in order to sorry, in order to kind of build like a large scale automated solution. So for all of these things, apart from having access to relevant technology, we also have to have like the right mindset to identify and curate kind of meaningful data sets. So now I'll be talking about the whole process of how we can approach dataset curation, and like feel free to ask any questions if something is kind of unclear. So for this, before we talk about how we can approach like this problem, we'll be mainly taking reference of three datasets that we have collected, and they're also publicly available on Kaggle. So first is like clothing fit dataset. So this datasets basically contains the details of fit feedback from customers based on their purchased clothing items, and they have other information like ratings, reviews, category information, and among other things. This dataset was collected specifically to tackle the product size recommendation problem. So which is to say that when we go online, let's say on Amazon, and we want to buy a clothing product, like we'll want to see that what size of the product we have to buy so that it fits us kind of perfectly. Now another data set is sarcasm data set. So past study in sarcasm detection usually had made use of data set from Twitter. uh, so they are collected based on the hashtags which are mentioned on Twitter, but they usually tend to be kind of noisy in terms of like label assignment and also the language used. So this data set was collected to overcome kind of the limitations from Twitter data sets. So we collected this data set from two websites. One was the Onion. I don't know if you have seen this website. So they usually post kind of sarcastic uh, articles on real life events. Then we collected non-sarcastic headlines from this website called HuffPost, and then we kind of combined uh, all the data collected from these two websites to create a kind of sarcasm data sets where sarcastic headlines are from the Onion. And lastly, we have like a news category data set. So this we extracted from HuffPost, and this has around 200,000 news headlines, and they're kind of categorized into various categories like political, sports, crime, and other categories like this. And we'll be using these data sets to kind of make different points when talking about data curation. So circling back to data curation, so we'll basically mostly talk about two aspects. So first one is when we have like a specific problem in mind um, that we want to address with the help of data. So in this case, we have a kind of a North Star that we can look for and have like a guided search approach. So we collected clothing fit data set and sarcasm data set with this paradigm in mind. And the other thing is, if you are just curious and want some interesting data points to collect, we'll follow unguided search approach. And both of these situations will have their challenges, and I'll kind of briefly go over each one of them. So first one is guided search. So this is basically when we have like a specific problem in mind and we want to collect like a data set to address that problem. So one of the biggest challenges for this guided search approach would be understanding the requirements of the problem in and out. While this task could be daunting, like we can share some pointers that might help you and like doing that. So first one would be defining the problem formally. So when we have like a specific problem in mind, it helps to kind of write down the problem statement in a sentence or two. So taking the example of size recommendation problem, um, so we can define the problem by saying that if we are given a user and a product which has different catalog sizes, let's say small, medium, large, our task is to recommend a product uh, whose size will fit the user well. So this is like a simple statement which kind of identifies all the key elements that we have to consider to in order to kind of address the problem using machine learning. So after we have this kind of uh, formal definition, we'll be able to kind of identify what all key actors we have that we have to consider in order to address the problem. So in this case, like it'll be kind of identifying the essential data signals. So which will be kind of user ID, product ID, the size of clothing that customer has purchased, and the fit feedback that they have given on that transaction. So the ID features are kind of essential in tying each of the transaction to a particular user or a product, and that will make like the data point unique. So undoubtedly we can collect other signals, for example like product category or user age, but these are not really necessary to kind of address the problem. Yeah. um cool. Yeah, let me know if you have like any questions along the way. And lastly, it will be kind of data volume requirement. After we have identified all the key elements, we want to make sure that we have sufficient data uh, uh, pertaining to all those key elements. So whenever we are looking for a data source on web, we want to see that that source has enough historical data so that we can gather a sufficiently large data set. So let's say if there's a site in which every product has only 10 reviews, maybe like it might not be worth kind of scraping that. But if the number of reviews for products are kind of sufficiently large, that also contributes to how well our machine learning models would work. So the second aspect, second paradigm, so to say, was like unguided search. And these are for kind of creative souls who don't have, let's say, any specific problem in mind, but still want to, let's say, contribute to the community by gathering some worthwhile data set. So for that, unguided search is like the way to go. And we'll refer to the news category data set to explain like various challenges for this kind of paradigm. So first, like the biggest challenge for this paradigm would be that there is a lot of uncertainty involved, because in guided search we had like a north star, and after defining formal problem statement we knew what all different elements we had. but here it's kind of all vague, and definitely it could be like very daunting. But hopefully, like following the upcoming pointers might kind of structure your approach and how you can like think about uh, contributing a worthwhile data set. So one of the signs for competent data set is that it has signals that can address some practical problem, um, or it can help you like explore some fascinating insights into some phenomena. So one example I'll give you here would be like the from the news category dataset. So in this dataset, we had like a headline for each article, and the label was like the news category for that article basically. So what it could help us is, let's say, uh, identifying the prose style or writing style for any particular category, let's say whether it is political or has a humorous tone or is a criminal report. So if we are able to do that and we are given like a simple piece of text, so then it becomes very interesting that you'll be able to kind of identify in which of the categories does this prose style fall in. So this is kind of really interesting to think about. And this could also be used in tagging, let's say, untracked news articles, um, which is like really useful. Then, apart from this, we also have to think about whether there's sufficient metadata available for um, in that web source. And this is particularly important because if we don't have enough metadata, we might not be able to engineer useful features later on. So one example I'll give here is for predicting, let's say, clothing sizes. It might help if we have like other kind of information, like product's price, or let's say the brand or the fabric of the product. And lastly, I think data volume requirement applies here as well. Although we have like a relaxed constraint that we are not kind of bound to collect dat- data for specific attributes. Let's say if we have some categories, let's say for news category data set, we had some categories which had under 500 news articles, so that we can simply kind of discard, because our goal is not to specifically predict certain categories, but to have just enough data in each category so that we can learn like the overall writing style, for example, in those categories. And lastly, like once like we have thought about all of these things, we also want to see whether there's already an existing data set available on this problem, because we want to contribute something like novel to the community. So if there is, like, we can think about how else like we can improve on it. So that is like one of the important things to check.
Um, Thanks, Rishabh. So now that we have an idea about two different approaches, guided and unguided, on how to build a data set, we have done like enough planning and plotting. Now let's switch gears and talk about the extraction process a little. So for extraction, the best thing, since we're at All Things Open, we'll talk about some open source tools we can use to basically collect data from web sources or any other source that you have. So talking about the toolkit, these are not necessary that these are the only tools available, but these are the ones that we chose and that we were comfortable using in. If you want to know more about, or are like more interested in programming and want to have like a code base to refer to or just reuse our code, feel free to like check out our ebook. We have links to the gist and GitHub repository you could use. And of course, it talks about the entire process and builds the code like line by line. So the first thing that in our toolkit was Chrome and Chrome driver. Chrome, for those of you who don't know, it's a popular cross-platform web browser. And apart from being great in privacy, speed, of course, not great in that privacy like as compared to others, but it's simply decent. Chrome also provides excellent tools for inspecting a website's raw code. So that was one. Then we use Chrome WebDriver, which is again an open source tool for automated testing of web apps across many browsers. It provides capabilities for navigating to web pages, user input, Java execution, and more. So it definitely helped us automate our scraping efforts. The next thing is beautiful soup, and I'm really sorry if I kind of like build up your appetite. We're not talking about soup, but we're talking about beautiful soup, which is a Python library widely used to pull data out of HTML and XML files. Beautiful soup unlocks the ability to navigate quickly and modify the HTML tree structure we have, and saves us hours and hours of work. Furthermore, it also allows us to write automated scripts to scrape the data from the web. And lastly, we used Selenium, which is a widely used framework for controlling web browsers through programs. Basically, you can enact what would happen when I click that button, or when I basically fill a form and so on. So just to like mimic human tasks. So when combined with Chrome driver and beautiful soup, Selenium allows us to automate like opening websites, navigating through pages, extracting data, and much more. So these three tools basically helped us make like a delicious recipe for our extraction toolkit. Um, so moving forward, there are like static and dynamic content that the website has. Again, not going into too much technical details because I'm not really sure how people, here are familiar with the code. But again, if you want to refer to the GitHub repository or the gist that we have, feel free to. The fixed part is just to put it in very simple words, the fixed part of the website is static, and the one that can change according to what action you perform is dynamic. Very, very simple words. The dynamic part is created on the fly. So depending on what type of content you have, static or dynamic, we have like different kind of like code pieces written to basically extract the required information from that particular part. Selenium definitely comes in handy, especially when I said when you click a button, when you log in, because certain information is available for like logged in users and certain is not. So it just helps you do that. And yeah, we can move on to like key information acquisition. As Rishabh was talking about specific data signals, this is the part where we'll be talking about how to extract, like the user ID, the product ID, the specific data signals that we have from like a particular web page or website.
Um, yeah. So basically, I was talking about determining essential data signals. So this is where we kind of try to narrow down a web source that can provide all the necessary signals in a sufficient quantity, basically. Um, and while doing that, we also have to keep in mind whether the source has static or dynamic content. And based on that, basically, we can devise a strategy and write down some scripts that will kind of execute all the things automatically. Um, so, like to give you an example of what kind of considerations we had put in for extracting the clothing size data set. So we had to think about what all web sources are providing user ID, product ID, fit feedback, and the size purchased. So we looked like we searched the web thoroughly. There were some promising websites like Zappos, which had all the information, but they didn't have like the size purchased reported from the customers. So that didn't really kind of work out well. But we came across this website called modcloth. So this had like all the information that we needed. So after we decided the web source, like we had to think about like how the site was structured, how the products were kind of presented, like in a grid form or a list form, and how to extract basically link for each of the product, and how the reviews were shown in each of the product, and what all product metadata was available. So there are like multitude of things that goes into kind of researching this. um, so the whole process with like code examples is available in a book, but basically we have to think about like a strategy that could work in writing a script, uh, and then kind of running it automatically to see how the data gets extracted. So on a similar line, uh, so basically running a one-off script is one matter, but if we have to kind of automate the whole process, we have to think about like a robust script as well. So we have to do like a lot of error handling, or see where all like let's say we have to perform like a button click, or log in onto a particular website. So this all you'll be able to kind of explore if let's say you try to automate a script, and this is like a trial and error kind of method. There's no like specific kind of guidance there. So once you hit kind of roadblock, you see like how to whether to do error handling, or whether to provide like credentials. So after a while, as you're collecting data, as you're scraping data, just make sure that you're kind of saving the current state once in a while, so that you don't lose all the data that has been extracted so far, and just try to build like a robust script. um, because usually if you are looking to build like a large enough data set, it could days it could take like multiple days. So yeah, basically the tools that we talked about are really kind of helpful in automating all the process kind of end to end. So next topic is dataset preparation. So extracting is just like one part, but we are still far off from like building like a quality data set, because till now whatever we have is just in a raw form, and we have to kind of basically groom our data set so that machine learning models could like work well. And there are like various processes that we can do on a raw data set. So first one is like data trimming. Um, so basically for this, whatever raw data we had collected so far, it's not necessarily the case that it will be in a best shape. So for example, let's say for clothing size data set, if we have collected, let's say thousands of reviews, it will not be the case that all the reviews would have like all the required information, like fit feedback or size purchased. So we need to either kind of remove all those transactions from our data set, or find like some clever way of producing the information we need. So let's say I'll give you one example. So from the ModCloth website, the from which like we collected clothing size data set, those didn't have a unique user ID assigned to each user, but they had like a username. And now if you think about it, username could be repeated across, let's say, multiple customers. So one idea we had was uh, while giving the review, we also the customers also had to provide other details like their age, or um, gender, or other types of measurements. So what we thought was that if we combine username with all of these unique information, we can build like a unique ID for each other user. And that was how like we were able to uh, kind of facilitate that process, which was ultimately kind of required uh, for building this unique data set. So after like we have thought about um removing redundancies and unwanted records, another thing that comes usually while preparing data set is data integration. So in an ideal scenario, like we can build our whole data set from a single web source, but that might not always be the case. For example, the sarcasm data set we built, that was built based on two web sources, and we have to then integrate it somehow, right? So basically data integration process allows us to kind of combine all the different pieces of raw extracted data we have and build them into a coherent kind of data set. So for that, like we have like um, two specific processes. One is kind of vertical integration. So if you think about the sarcasm detection data set, so we had non-sarcastic data from one source and sarcastic data from other source. So vertical integration says that we just combine all the records from one source to the other source, and ultimately we kind of shuffle all the records we have collected, because if a learning model is trying to learn from that data set, um, it could be really biased if it goes through all the sarcastic records first and then non-sarcastic. So shuffling like is like a really important part in like vertical integration. Then we have like horizontal integration as well. So let's think about data set related to cities. So it might not be the case that all the information for a particular city is available in one web source. So we are looking at things like the state, country, area, population, climate, pollution, and things like that. And it might be the case that some information is available in one source and some in other. So in this case, we basically have to combine both the information using like a unique primary key that you might be aware of from like SQL, and based on that we do just like horizontal integration. So basically the idea for this is like building one unique data set at the end, even though we might be extracting things from many different sources. So another thing is data transformation. So in this case, basically, let's say we are collecting reviews from a particular website. There could be like many things, like let's say the size feedback is given in written form. Let's say um whether the product is small, large, or fit, that is given in text. But let's say if you want to solve the problem using machine learning, we maybe want to encode that into numbers. Let's say 0 corresponds to small, 1 corresponds to fit, 2 corresponds to large, so that we can encode like the inherent dependencies between these kind of signals, which is not available in textual format. uh, so for this, like data transformation is kind of useful. And another thing could be there could be like impurities in the review text. So there could be like grammatical mistakes or punctuation marks, which are not really helpful for our model to learn. So in this case, like we just remove all those so that like we have like a good quality data set at the end. Um, yeah.
Um, so in the next segment, we wanted to talk about feature engineering and basically how we can, now that we have a data set, but the machine learning models might not be able to understand like what small is, what large is, because all they care about is numbers and zeros and ones and digits. Before we talk about maybe feature engineering and the different techniques of say feature importance, feature correlation, like it depends on the audience. Like, do you want to go on a break? Because talks at 3:45 and then we start the next session at 4 p.m. So probably like if you want to know more about like feature engineering, I can just give an overview so that you're motivated enough to come back at 4 p.m. So basically we'll be talking about the like the techniques, what is feature engineering and particularly what is not feature engineering, feature correlation, feature importance, feature explosion, course of dimensionality, and all that stuff, which basically is forms the end part before all this information is consumed by the model itself. Feel free to come back at 4 p.m. for the next segment of the talk. Thank you so much for staying for this session. If you have any specific questions, feel free to ask. I know the starting part could be a more theoretical because again, it's very use case dependent on what kind of approach should I take and what I don't, and it's very hard to compress all that information in just like a 35 to 45 minute segment. But yeah, feel free to like follow us on Twitter. Feel free to read the book, and in case any if you have any follow-up questions for this segment, you can approach us anytime. Thank you so much. Thank you everyone for coming for the second segment of the talk, which focuses more on feature engineering. Now that we have talked about data extraction and data set preparation, we need to move on to the next stage, which would be the final stage before we actually put all of this information to a model, to a prediction model, which would make help make good decisions. Um, so, to talk about feature engineering, it is the process of transforming raw data that we had into features that better represent the underlying problem of the predictive models, resulting in an improved model accuracy on unseen data. So basically, you have to like quantify the values that you have from all the raw data that we collected or we have present in our data set. What a feature comprises is basically an attribute or property shared by all the independent units. Basically, if I have, let's say, a size of a product, for a particular product, I should also have size of all the remaining products for it to be basically input into the predictive model that I'm building. Um, Feature engineering is one of the key techniques that often does not get its due limelight. Much of the success of machine learning is actually success in engineering such kind of features that the learning algorithm can understand and can generalize from. This is where basically your intuition comes into play and what your like domain knowledge comes into play, along with your creativity in like combining different features and combining data to form new features, and black art, as we say, because this is not something that you can just like list down rules that you should have like this feature and this feature. This comes from like more of like experience and trial and error. This step actually is much more important than the ML algorithm or the model itself, because as we know, state of the art learning algorithms, they're as good as the data is. As you can see, there's a publication, a few useful things to know about machine learning, and it says feature engineering is the key, and I cannot emphasize any more on this. um, Choosing the right kind of feature in right format can by far boost performance of simpler machine learning models. Your model can be as simple, but if your features are very complex and very thought out, it definitely helps your model boost its performance by a lot. um, as we know, garbage in, garbage out, and it works absolutely true in cases of machine learning models as well. Having good features not only increases the transparency of the model, but also helps it makes it easier to understand for the model and to it make predictions. Having good feature engineering process in place reduces the need to use heavy and complex ensemble learning techniques, thus having a more explainable model in place. It also reduces need for tuning hyperparameters and optimizing every other day if you have like good feature engineering process in place. So now that we've emphasized on a lot that the process is important, but what is the actual process that goes behind feature engineering. um, so this step, as I said, like is much more than the machine learning model. So a lot of research goes into place even in industrial setting. As a machine learning engineer at Twitter, I can vouch for the fact that we do spend a lot of time thinking about features and then implementing them. So, what you start with is analyzing trends, researching the domain, and coming up with an idea. Then you discuss with people, brainstorm, thinking if it's actually relevant to your problem or not. And then you do like offline transformations, as Rishabh talked in our previous segment about, encoding them, removing unnecessary parts of the. To give you an example, for example, if you have like a text snippet, just removing punctuation words and stop words, punctuation marks, etc., definitely helps extract the meaningful stuff out of the text snippet that you have. After having like quick offline transformation, you perform statistical analysis, and then you test with the existing model you have in place in an offline setting without, maybe like on a smaller data set, or without basically serving the online traffic. If you are in industrial setting, for example, at bigger companies that serve models on their websites, if it doesn't work, you go back to the brainstorming and try improving your feature idea. If it does, you go work on productionizing it, integrating in an online pipeline, running it online, and continuing the process, and so on. So this is basically a cyclic approach that we have to feature engineering. Of course, there are no like hard and fast rules. You have to form feature ideas and transform them as and when you feel the need to, and as it improves your model performance. So Andrew and G has put it in like very nicer terms that coming up with features is difficult and time consuming and requires a lot of expert knowledge. But feature engineering is nothing but applied machine learning. So feature engineering helps machine learning, but feature engineering itself is applied machine learning, because without models you cannot test if a feature is good enough or not. It might look good on paper, but it might not be as good on um, during performance or model accuracy. So while we're talking about feature engineering, it is also very important to understand what are the non goals of feature engineering, or like what is not feature engineering. So while we were creating our data set, we thought about, data scraping and collection and approaches we talked about. They definitely don't form feature engineering, because the raw data that we collected, you cannot directly input into your machine learning model. So it's very necessary to understand that the stuff you can use the model can use is what feature engineering comprises of. So, for example, having a label or deciding what the target variable would be, again, does not come into feature engineering. Then the data cleaning part that we discussed about, removing duplicates, handling missing values, etc., again, do not form part of feature engineering. And so is like stuff like scaling the values, normalizing them, and all that comes under like data set preparation or like data pre-processing. So, if you consider data to be the crude oil, features are basically the fuel we need for a machine learning model. So we can talk about the different techniques, just to give you an example of like what feature engineering would be. So let's say you have an app store page. You have like an app on the app store, and you have collected information from it, like what app store it belongs to, what like number of app languages it supports, like say English, Hindi, and French, and so on. How old is the app? Like, let's say it was published like 1350 days ago. And what's the rating of the app on the App Store? So let's say this is the kind of data that we have extracted while doing the data set preparation. Now, to create features out of it, it's a different job altogether. So let's say how we transformed it into features. So when we had App Store, I created like an array kind of a thing where different I'm talking about the approach one hot encoding. So what I did was I fixed my array that the first would mean Google Play Store, the second would mean iOS App Store, and then I kept a few buffers, in case any other company maybe next day comes up with their own app store. And then I like symbolized one with Google app Play Store if the app is present on Google Play Store. For this particular example, I think I'm mistaken. I should have like one on the second place, because iOS App Store is the one that should be lit up as a signal, if you think so. The second would be app category. Now, if I have app category as social is not something your model would understand, because they would need like as I said, model only understands digits, numbers. So for that, I had like a predefined category of apps, like as an array, like travel, social, business, productivity. And then I again lit up this particular place where social would correspond to. Now, for app languages, I might have an app might be present in different languages. So for this, we would have like multi-hot encoding. In, for example, like multiple places would be lit up. If you think in terms of signals for thing, for example, here you can see English, Hindi, French, etc. They were all like different places were lit up for 1001 and so on. And then app age days was something that was already in numbers, so we didn't have to like transform it. Again, same goes for app rating. The only thing is we would have to make sure that everything is in the same format for feature engineering to work. um, Now, of course, we've talked about like we can make multiple features, but for them to be worthwhile enough for the model to give them maximum signal, what actually makes a good feature? So, good feature, there are certain like guidelines I can talk about. So, first would be avoid rarely used discrete values. For example, let's say you have a data set, but the app rating 5 on 5 only comes like 3 times. It might be a good value to have, but again, it might be more of like an outlier detection. So maybe have like a threshold depending on the percentage of, let's say if you have like 1 million apps, maybe 10% of the apps should have like 5 rating or so on. It's just to have like a balanced data set and not to have an imbalanced data set. Otherwise, your problem would be more of like an outlier detection or like a non-only detection, because you need to have the features which provide enough differentiating power and not have minorities which would basically overshadow and get neglected instead. The second would be prefer clear and obvious meanings. If you saw in my previous example, I had app age. Now, app age could be in terms of years, it could be in terms of months, it could be in terms of seconds. For example, if you have like a new engineer or just someone from a different domain who's trying to understand, because explainable AI is so much into talks these days, it should be very clear for someone to understand what this feature exactly means. So having a feature name such as app age days clearly like indicates that the age of the app is in days. So that helps anyone working on the project to have like clear feature names as well, and that also comes under feature engineering. The second would be dealing with value discontinuities. So let's talk about the feature that we have, app rating. So app rating can be, if you know, in general terms, between 1 and 5, or maybe like from 0, and it could be like decimal values as well. But something of app rating as -1 is not something that is a viable or a feasible option. To maybe mark these explicit values so that someone that the model is trained to ignore these would be have an is app rating defined, or just like have the model ignore the values where this could be even come under data pre-processing, where you just ignore the values which are like less than 1 or greater than 5 and so on. And the second would be the fourth point would be avoiding mapping for value stability. For example, when we talked about languages, different languages, we could have like a mapping, like a third party mapping, which we maintain, where each language is mapped to a specific value. But what if you add new languages or you delete languages? The value would the mapping would still hold or not? And it creates like another basically a third party thing or a liability for you to maintain. So it's better to have the feature maybe encode it in multi-hot encoding or create the encoding on the fly, so that you don't have that third party thing going on, or liability so that you have to regularly maintain. So instead of using app language as 24, always use app language as English, and then while you're doing the processing, while just inputting it to the model, do that encoding stuff. So a definition of the feature should not change over time. For example, if I had that a third party mapping kind of a thing where I map a language to a value, someone would come and change it, even though it might not be incorrect, but it would change the model, if especially if you're doing like online training, like the training is happening on batches of data every other day. So try to avoid those kind of mappings. So these were some of the pointers that you could keep in mind while doing feature engineering. Um, Now we can talk about curse of dimensionality. Um, so anyone here familiar with the idea of curse of dimensionality in feature engineering? So yeah, feel free to. Okay, cool. No worries. Yeah. So now that we've talked about like how features are very, very important to machine learning, it is also important to note that when you have too many features, it just bloats up the feature space, and it's not good to have too many features as well, because it like just affects the generalizability of the model, or to say. So with too many features, which bloat up even more if you use techniques like bloat encoding and embedding. The observations just become hard to cluster, and exponentially more data is required, because if you grow your data set like or your input in breadth, you also need to increase your input in depth, so that you have like a viable source of data for the model to generalize. So too many dimensions cause every observation to appear like equidistant from each other, and leading to much harder problem and poor performance. And that's what leads to feature explosion. And feature explosion is basically a quick growth in the number of features horizontally, if we see data as rows versus columns. So you can stop feature explosion by, though you have like lots of ideas, you can keep them on paper, but then use techniques like regularization, kernel methods, feature selection, and so on, to basically select only that particular subset of features that are important to your model. And which takes us to the part of like feature selection. How do we actually select those features, those subset of features which are important to the model? And maybe Rishabh can talk more about that.
Yeah. So now we are at a point that like we have thought about like all the features that we want to include in our model, and we were talking about this feature explosion problem, which is basically when we do like too much feature engineering and try to come up with a lot of features. We'll frequently come across this explosion problem, that having too many features would require uh, much larger data set as well. And if we see that during the data extraction process, we don't have, uh, let's say, a million records in our data set, it is then become very important to like think about feature selection and only keeping the most useful feature in a model. So like the name says, it's a process of selecting like a subset of relevant features, which will be like the most useful for our machine learning model. And this basically allows us to eliminate uh, like irrelevant attributes as well, that may be like just noise to the model and might be hurting our like model prediction capabilities. So after we kind of cut down unrequired features, our model becomes like simple as well, in terms that it doesn't kind of overfit on the data, and it is much easier to interpret. And if we cut down, let's say, the number of features, like in industry, when we are serving the model, like we have to do like feature hydration and prediction on the fly. And if we have, let's say, thousands of features, our model prediction would be like really slow. So that also leads to like maybe bad customer experience. So for example, let's say I'm trying to view replies on a particular tweet, where the replies would be ranked, and then for each of the replies, let's say there are thousands of replies, for each of them we have to do feature population, then output like a good model score. So all of this, if you have too many features, it takes, let's say, 5 to 10 seconds. Maybe like customers will go away, and that will not be like really good experience. And then it also protects against like curse of dimensionality. So in that aspect, like feature importance is like a similar concept, but it helps in kind of ranking our features, so that we can only select the most useful ones. um, and if we are able to kind of describe like the importance of each feature, that also helps in interpretability and explainability of the ML models. So for example, let's say if you are trying to predict the rating of the app, and if we say that app price is like the most important feature, and then maybe the language of the app store description, like that carries a lot of value nowadays. So for feature importance, I'll give like one example where randomized decision trees like can be useful. So if you have heard about decision trees, basically uh, for all the features, we try to see which one is the most informative one, and based on that, we take some decisions, and that process is continued until we reach the leaves of the decision tree, where we make like the final kind of classification. And the way we kind of split the data based on the features is how much information like we are able to how much uniformity we are creating by dividing our data set into like different groups based on certain feature. So that kind of communicates how important a certain feature could be. And after that, like whatever feature we are using to split most of our data on, so that will be kind of most valuable to us. And higher the score, like the more important that feature would be. And maybe like we are able to get kind of these kind of scores for each of the features we use. And at the end, it depends on our budget. Let's say we are given 500 milliseconds to produce our model prediction output. So we'll just try to do this experimentally, where first we'll take, let's say, 5 features or 3 features and see which one is more optimized and not hurting like the our overall objective as much. So yeah, after this, like this may be true for all personal and professional relationships. So this applies to kind of machine learning features as well, that in a sense that um, among the features there could be like various relationships, and it is important to explore that as well. As I'll be talking about like some of the things, like the values this process could provide, and we'll be studying this graph soon enough, where basically we are tracking number of app installs on one axis, and on the other axis we are looking at the values of various features like app price, app rating, and app languages. So in that direction, I want to talk about like feature correlation. um, so understanding relationships between multiple attributes in the dataset is called as correlation, and this could lead to like multiple useful insights. um, so let's see, I'll just take example here for like more understanding. So let's say we have this app installs on x-axis, and we are tracking app price. So we'll see that as the app price goes uh, uh, as the app price kind of increases, as the app price kind of increases. So actually like we have to look from this side. So as the app, sorry, like yeah, I'm not able to show the cursor, but let's say when the app price is kind of around zero, we are able to see 20,000 installs. But as it increases to around, let's say, five, the number of installs kind of decrease very significantly. On the other hand, if we look at the app rating, if the app rating is lower to around, let's say, 1, we see like very less app installs. So this is like the green line. And as we go uh, approximately to rating 5, like we see like a huge increase um, in the app installs. So basically, for both of these things, we can say there's a positive correlation between app rating and number of app installs, and there's a negative correlation between uh, app price and app install. And there could also be some features like app languages, which is the orange line, uh, which basically maybe it doesn't matter like what value it has. Like the number of app installs are not kind of dependent on uh, app languages. So why is it important to see this trend basically? So one thing is like this could allow us to predict one attribute from the other. So let's say you have a data set where for one attribute, let's say app rating, that is always present, but you can't always get, uh, let's say, app price, for example, right? So in that case, if we look at like the relationship between app rating and app price, it may seem that they are kind of inversely correlated, uh, and that will kind of help us in guiding the feature imputation process, where we can say that if, let's say, the rating is around 5, most probably the app price would be lower. So that gives us like one informative way to kind of populate missing features values. Cool. And after this, like let's just talk briefly about feature automation. So mostly the process I've talked about for now, it's all kind of manual and it could be like really exhaustive. um, and there are certain principles that basically are guiding this feature engineering process. And if we can encode these features somehow, encode these principles somehow, like we can have like a automated process that generates a feature. So it is important to kind of encode domain knowledge, intuition, and various processes that we have talked about in the automation process. And we have some open source tools like feature tools, which is like a Python framework, which are able to kind of have like certain parameters as input and output like a very informative set of incremental features that we can then try out in the model. Just like we have to just consider one thing in this is that um, using some automated process to kind of generate the features would definitely kind of blow up the feature space. So then we can after, let's say, we have some informative set of features to begin with, like we can use the feature selection process and try to reduce the space so that we still keep like the most informative features while utilizing like the automated process of feature engineering. So there's this one of the quotes by Pedro Domingos. He says that one of the holy grails of machine learning is to automate more and more feature engineering process. And yeah, this is becoming true, more and more true, like as we try to kind of scale up the machine learning deployment efforts. So yeah, this is one quote. like which could be like a good takeaway, that good and reliable feature engineering is like laying a strong foundation for ML modeling. If like we have like very informative features, like that'll allow our machine learning models to do well. Yeah, Jigyasa can
Yeah, so the bottom line is that in the workflow that we usually follow for machine learning is defining a formal problem statement, developing an intuition of how machine learning can tackle the problem and its challenges, sourcing the data that we talked about in our first segment, and fabricating our own data set, processing the data set, performing feature engineering, defining appropriate metrics to measure the success of the intelligent solution, and then choosing the appropriate model for learning algorithm to address the problem, deploying and then maintaining. So in this workflow, usually most of the people basically focus more on defining the appropriate metrics and then choosing appropriate model and for the learning algorithm to address the problem. But it is also very very necessary to focus on the previous two parts that we basically talked about in this talk, is sourcing the right kind of data, fabricating our own data set, and processing that data set to create features, which would be much more important. And if we focus on these two aspects, we should consider half of our work done for machine learning modeling. So that would be the biggest takeaway from this extended session. And to back up this fact that it's not only us that we are like basically championing the fact for a data centric approach to machine learning, because Andrew Ng, who is renowned in this field, also mentioned that AI is equal to code plus data. And so far we focus so much on the code that easily it's available to have like pre-trained models and so on, but what is fueling that part is the data that goes behind. Enough of the success that we had is mostly for fixing the data part and focusing more on the code. Now it's the time to fixing the code part and focusing more on the data. And with that, if you're interested more to learn about curating the right kind of data for your machine learning, we recently co-authored a book titled Sculpting Data for Machine Learning. It's available on Amazon, both as ebook and paperback. Feel free to check it out. We also had a book signing prior to this session. Um, it focuses, just to give a gist of, it focuses on the significance of data in machine learning and give pointers on how to identify relevant data signals. It also talks about end-to-end process of data collection and data set construction, along with open source tools like Beautiful Soup, Selenium, and gives a synopsis of machine learning paradigms from a data perspective. And it's endorsed by machine learning experts, Julian Macaulay, Lawrence Morney from Google, and then Mengting Wong from Microsoft. Um, Thank you so much, and hope you had something to learn from today's session. Feel free to reach out for questions if you have any. Thanks a lot.